In this video, we are going to see the introduction of the chapter triangles. So let us start the discussion from the definition of the triangles. Triangle is a closed figure having three sides. We know that the triangle has three vertices, three sides and three angles, right? Last year, we already have discussed about congruent figures. So first of all, once again, we'll see what exactly are the congruent figures. We know that two figures are said to be congruent if they overlap each other exactly, right? After that, we have seen that two figures will be congruent if their shape and size are same. Then only it will be possible for us to see that they are exactly overlapping. So for being congruent figures, size and shape of two given figures must be exactly same. Now if we discuss about two congruent triangles, two triangles will be congruent if and only if all the corresponding sides are equal as well as all the corresponding angles will be equal. If all the corresponding sides will be equal, then there will be same size, and if all the corresponding angles will be equal, then there will be same shape, right? So for holding the same size, sides need to be equal, and for holding the same shape, angles need to be equal. So this is about two congruent triangles. This year we are going to see another concept regarding the figures. We are going to see the similar figures this year. For congruency, we require shape as well as size exactly the same. But for similarity, shape must be same but size may be different. Getting it? So two figures are said to be similar if their shape is same but size is different. In order to understand this definition, let us take an example. Let us consider circles, three different circles, right? Now in this figure you can see that there are three different circles. We know that each of the circle has the same shape. It is round, but their sizes are different. So here we can say that these three circles are similar to each other. To talk about practical examples, if we see the model of a car and original car, each and everything is same. Only the difference is in size. Original car and model of the car, each and everything you will find same, but there will be difference in the size. Similarly, we have so many examples, right, to understand the similarity. Getting it? Now after this, here one more thing we can say is, if we have two congruent figures, now we can say that all the congruent figures are always similar, because congruent figures have same shape and same size also. Now for similar figures, we require only one important thing, is that their shape should be same. Size doesn't matter. So for congruent figures, shape is same and size is also same. So it is satisfying the definition of the similarity too. So if we have given two circles like above example, we can clearly say that both the circles are similar if they have same size. And even they do not have same size, then also we can say that we can say that they have same shape, right? So considering that, we can say that all the congruent figures are always similar, but similar figures need not to be congruent. Now in the above example, if you see, these are the three circles. Definitely we can say that they are similar, but they are not congruent because they will not overlap each other exactly. Getting it? So this is a very important note. You have to always remember that if we have given two congruent figures, then they are always similar, but the similar figures need not to be congruent always, right? Now let us discuss about the similar triangles. Two triangles are similar if and only if they have same shape but different sides. So let us define the similar triangles first. Two triangles are said to be similar if and only if, first thing, all the corresponding angles are equal. If corresponding angles are equal, both the triangles will hold the same shape. And second thing, all the corresponding sides are in proportion. So corresponding sides will be in the proportion if and only if the ratios of all the corresponding sides are equal. And if the corresponding sides are in proportion, they will hold their sizes will be different, right? Now let us consider triangle ABC and triangle PQR. If in triangle ABC and triangle PQR, if angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. This is the first part. And the second thing which we require here is, if we take the ratios of the corresponding sides, that is AB upon PQ, BC upon QR, and AC upon PR, and if all these ratios are equal, we can say that corresponding sides of both these triangles are in proportion. Then this triangle ABC is similar to triangle PQR, and it is true vice versa also. We will see it in the next slide. But remember this. So if in two triangles all the corresponding angles are equal and corresponding sides are in proportion, then both these triangles are similar, right? And if the triangles are similar, then we can write corresponding sides are in proportion and corresponding angles are equal. The corresponding angles of similar triangles are considered as CAST, corresponding angles of similar triangles, and corresponding sides as CSST, corresponding sides of similar triangles. Together, angles and sides of similar triangles are considered as parts of the similar triangle. So we will denote it by CPST. Now let us discuss something more about the similar triangles. Already we have seen the definition of the similar triangles. Now let us see the converse part of the definition of the similar triangles. So if given two triangles are similar, then symbolically we write it as triangle ABC is similar to triangle PQR, where we use inverted S in between given two triangles, which is the symbol of similarity. Okay, then if triangle ABC is similar to triangle PQR, then we can write all the corresponding angles are equal, right? And second thing, all the corresponding sides are in proportion. Means if we take ratios of the corresponding sides, then those ratios are equal. Then only we can say that all the corresponding sides are in proportion. Now, as all the corresponding angles are equal, they are called as CAST, and corresponding sides are called as CSST. Angles and sides up to similar triangles. In fact, corresponding angles and sides of two similar triangles together can be denoted by CPST, because angles and sides of two similar triangles are considered as parts of the similar triangles.